everyone. Today we will study the next part. Okay. Yesterday we have studied the first part in the flow chart. That is, metals are divided into three: highly reactive, moderately reactive, and least reactive. Yesterday we studied about. Okay. Today we are going to see the things which we are seeing in the middle of the reactivity series. That is, moderately reactive metals. Usually, tell me some metals which come in the moderately reactive. It may be iron, it may be zinc, it may be copper, right? Okay, we'll study about these three metals: iron, zinc, and copper. Usually, they will be in the form of sulfides or carbonates. What do you mean by that? They will always be friends with sulfides or carbonates. Okay, but when getting from the ore, what is our aim? Our aim is to get the pure metal. When you are getting pure metal from that, it will be easy for us when we can get it from oxide compared to that of sulfide or carbonate. Okay, we will see how it is going to happen. Okay, come have a look. The first one is iron, zinc, and copper. They are present in the form of sulfides or carbonates. Okay, it may be in the form of sulfides or carbonates. For example, can you tell that sulfide, when it combines with zinc, zinc sulfide. When it combines with carbon, zinc carbonate. Copper, same way, copper sulfide, copper carbonates. Like that combination can be seen. Okay. Now, I told you it is very easy to obtain from oxides compared to that of sulfides or carbonates. Now, sulfides or carbonates are converted into what? They are converted into oxides. Okay. Sulfides and carbonates are converted into oxides. And then the oxides are converted into pure metal. Then we are going to see how it works. We are going to see two different terms today. That is calcination and roasting. Repeat with me. Calcination and roasting. See here, calcination means carbonate ores. I told you that it may be in the form of sulfide ores or carbonate ores. Carbonate ores can be converted into oxide ore with the help of oxygen. Right? No. Absence of oxygen. Keep this in mind. Okay. When we are not already in the absence of oxygen, when we are heating it, you will get the particular oxide. But here, when you are converting it from sulfide to oxide, we will heat it with the help of oxygen. Okay, so two things. Calcination means converting the carbonate ores into oxide ores in the absence of oxygen. That is called as calcination. Then you are converting the sulfide ore into oxides with the help of oxygen. That is called as roasting. Okay, calcination and roasting. We will see some examples. See here, I told you that sulfide ore and carbonate ore. I have given one example. ZnS, zinc sulfide plus oxygen. When you are heating it, you will get zinc oxide. Our aim is that only, no? From sulfide ore, it should be converted into oxide ore. So ZnO plus what is the byproduct? Sulfur dioxide. Zinc carbonate also same way. When you are heating, you will be getting zinc oxide plus carbon dioxide. So both the times you will be getting one oxide. This is also oxide. This is also oxide. I told you that this oxide should be converted into pure metal. So zinc oxide plus, who is this person? Carbon, right? So who is this carbon? It's a reducing agent. Okay. The oxide can be converted into pure metal with the help of reducing agents. See here, I have given the definition also. Metal oxides are reduced to metals by using suitable reducing agents. They will reduce. We have studied about oxidation reduction, no? In which chapter? Yes, we have studied combination reaction, decomposition reaction, displacement, double displacement, oxidation and reduction. Same thing will happen here. Some of the examples are what? Carbon, sodium, calcium, aluminium. All these things can be used, but whichever is needed for that particular metal, we will be using that. Here carbon is needed, so we have used carbon as a reducing agent and we will be getting zinc plus carbon monoxide. We will see some more examples. Okay. See here, Mn. What is that? Manganese or magnesium? Manganese. MnO2. Manganese. Or find out the name of this. Okay. MnO2. Manganese dioxide or manganese oxide. aluminium, when you are heating, what will you get? You will get the pure metal. This is an oxide. But find out whether it is manganese oxide or manganese dioxide. Okay. Manganese plus aluminium oxide plus heat. Enormous heat will be produced. Same way, one more example I have taken, iron oxide. See, Fe2O3 plus aluminium, when heated gives iron plus aluminium oxide plus enormous heat will be produced. This we have studied, no? For heat, we can represent it in the form of triangle. This reaction is called as thermite reaction. What? With iron oxide, when you are heating iron oxide plus aluminium, you will get iron plus aluminium oxide. No? This reaction is called as thermite reaction. Have you ever thought that when you are having some problem in some machine, what will we do? We will take it to the shop and we will get it repaired and we will bring it back. What will happen if some problem happens in the railway track? Keep thinking. We will see the reducing agent or these four things, and thermite reaction I will explain it. Aluminium metal, see here this is aluminium metal, no? Aluminium metal is oxidized by an oxide of another metal. This is an oxide of another metal. So aluminium is oxidized by an oxide of another metal. Okay, thermite reaction I am speaking about. It will be stable at room temperature, but when you heat it, when you ignite it, what happens? Enormous heat will be produced. Okay, and it is exothermic. We know exothermic, endothermic we have studied. It is usually used for cutting or welding. Okay, this thermite reaction is used in cutting or welding. Now you got an idea, I think. What will they do in welding? Yes. For example, railway tracks. It is not only used for that, it is also used to purify the ores of some metals. Okay, in the purification also it is useful. So shall we have a quick recap of what we have studied today? Today we are going to studied about moderately reactive metals. In that we have studied what is calcination and roasting, what are the metals we are taking, and we studied some examples, some equations like from sulfate how oxide will be formed, from carbonate how oxide will be formed, from oxide how can we get the pure metal, and we have also studied about reducing agents, examples for reducing agents, and then two more examples to explain this, and I have explained also about thermite reaction. Study this thoroughly. Tomorrow we will be studying about the other thing which is left out.